Pipe supports and restraints not only carry the pipe weight but also take attachments weight like flange, valve, indicators, inline instrument, insulation, lining, and additionally external forces like wind and earthquake. The restraints limit the piping system to control their movement by resisting the loads that are due to thermal expansion, wind, earthquake, and vibration. Both restraints and supports are collectively called pipe support. Different pipe support types are specifically produced by manufacturers, which are called support devices or flexible supports. These are spring support, snubber, and sway braces. They are flexible because they move in 3 directions. Rigid supports move in 2 directions, horizontally or laterally but not vertically. A bare pipe can rest on a beam of a structure. This is the simplest way to support a pipe. However, due to thermal movement, the pipe may erode following the cyclic conditions of the line. To prevent this, you can use a pad that welded on the surface of the pipe. Pipe support with or without a pad is the most economical solution, but due to thermal expansion and external forces, restraints will be required. The restraints limit the movement of the pipe in 3 directions due to thermal or occasional movement, and resist the forces due to thermal or occasional forces. This is a stopper, or you can call it stop. This restrains the line in the longitudinal direction. This one is a guide. As the name implies, this one guides the line in a defined distance or gap. All these restraints can be designed in many different ways. The companies prepare their standard support details that are for reducing the cost and improving constructability. Up to 10-inch pipe, the lines can be rest on the structure beam without any support, if there is no insulation requirement on the line. For the insulated lines, an inverted T-profile or manufactured T-shapes can be placed and welded to the pipe. For larger lines between 12-inch to 24-inch pipe, hot-rolled H-profiles should be used as a pipe shoe. This is because of heavier piping. So, the load will be divided in 2. Rather than the H-profile, a shoe made of individual plates can also be used. Operating temperatures higher than 400 degrees Celsius, a shoe made of trunnion or a clamped shoe will be required. Because the junction of the pipe shell and shoe will contain excessive stresses due to high thermal expansion. Pipe sizes larger than 24-inch are required to be supported by saddles. The pipe shell of a large pipe has a higher tendency to deform at a support location due to relatively high self-weight, high radius-to-thickness ratio, and smaller internal pressure. So, engineers should consider the support requirements of large pipes for each case. Because the deformation in support locations is related to the internal pressure, thickness, and diameter of the pipe. The allowable support span is determined by stress and displacement criteria. The beam deflection approach is the evaluation method for support spacing calculation. However, this is not applicable for any concentrated loads like flange or valve on the line and is also not valid for overhanging pipe spans. The allowable span is to be taken from the smallest of L1 and L2 equations, where the Z is the section of modulus of the pipe, S is the design bending stress, and delta is the deflection of the pipe. Design bending stress value can be taken as 19 megapascal according to the Kellogg Company, 16 megapascal according to ASMEB 31.1 and 10 megapascal according to EN 13480. The different values are due to the accepted safety factors. For an overhanging span, a quarter circle approach can be used as shown. The overhanging distance can be assigned according to the diagram output. In the intricate landscape of pipe support systems, precision in engineering decisions ensures the longevity and reliability of oil and gas industry piping systems. As we navigate through the complexities of temperature considerations, load distribution, and support span calculations, it becomes evident that a meticulous approach is indispensable for maintaining the integrity of the critical systems. If you liked the video, please subscribe and hit the like button for more videos.